Hello, my name is Alan Zhang, and this is Lab 3, Black Hole. So, this lab has two parts, both with different purposes. And this lab is no physical experiment, only coding. So, part 1's purpose is to find the mass of a black hole through the motion of a star. And then part 2's purpose is using the mass in part 1 to find the initial velocity required for the spaceship in order for the spaceship to get near the black hole without crashing and then still leaving the system. In this slide, you can see the preview of the final answers. This is the mass, and these are the speeds. So next we have to go into the fundamental theorems of physics used. So we use Newton's second law, as F net is equal to change in momentum over change in time, and then gravitational force, which is this equation right here, and is used to find the force exerted by an object on another object in terms of gravity. So let's get into it. For part 1, I created the trajectory using my GT email, which is not shown here, and then shown in this image are the constants for the lab. These were all given when the original code was imported. So next is how the purpose was achieved. So from the code, we found our initial and final momentum using P is equal to mv. And then afterwards, we had right here, we have that F net is equal to dp dt. And then from here, we simply use the equation for F parallel in code form, which is this. This will directly translate to this piece right here. And afterwards, we found our perpendicular force by doing simply using F net minus the force parallel is equal to force perpendicular, because F net is equal to force perpendicular plus force parallel. So at the bottom right here, you can see that this is the code we use to find mass, which will be further explained in the next slide. So this is how we find mass. We start off with the gravitational formula, and then we have to move over r squared. And then from here, we are stuck with g over m of the black hole, and with the star is equal to F net times r squared. And then we have to get rid of g, and we have to get a mass of the star, which will leave us with mass of the black hole is equal to F net times r squared over g times the mass of the star. So next thing is the code results. So here's the code running. So due to the fact that the code gave so many slightly different masses due to F net changing caused by the orbit, because r is changing depending on the location, we have to find the average of all the masses and assume that m average, or mass average, is equal to the mass. So right here is the Excel code in the work. So we imported all of the different masses from the code and pushed it onto an Excel sheet, and then we used sum of the column to get the overall the total mass from all of the different code outputs, and then from there we divided it by the total amount, and then we found that the average mass is 2.04 times 10 to the 34th power kilograms. Here's part 2. So right here we have the constants that were given for part 2. So as you can see here, I pushed the mass of the black hole from the previous code into this batch of code. So this next slide is finding the forces on the planet and the spaceship. So this code is simply just the gravitational formula used twice on two different objects. So this is the formula of the gravitational formula, and all this code does is, again, it just does it twice. So I won't go into too much detail here, but this right here is the code to find F net on planet, and then this right here is to find F net on the ship. So after we found initial velocity through guessing and checking, like the instructions said, as you can see, that this initial velocity led to this, which is the fact that the spaceship escaped the black hole, which means that the goal of part 2 is now accomplished. So now both parts are complete, we need to cover what are the possible errors of the lab and the system and surroundings. So the systems and surrounding, part 1, the system is the black hole, surrounding is the star. Part 2, system is the spaceship, surroundings are the planet and the black hole. Now these are the possible errors. So 1, the lab is a simulation, so it's in ideal conditions, assuming no other forces, which in reality is unlikely, and therefore this is a very obvious source of error. And then the other thing is accuracy. So due to the fact that we're using trial and error values, these can lead to inaccuracies in the last final output. So these are discussion questions. So first one is, what does it mean? So what is the difference between momentum and force net? And mathematically, the same. However, net force, you need to know every individual force acting on the system. However, the rate of change in momentum you'll need to find the information about the system and its change in velocity and motion. So the what if is, what is the initial velocity for the spaceship to make orbit around the black hole? So this is the black hole in the orbit, and this was the spaceship speed. So this is lab 3. Thank you.